Every single day we tap, we swipe, we send, we connect to the whole world through our phones without giving it a second thought. But behind that little glass screen, there's this invisible, super high-speed universe of signals and gateways and security checks. So today, we're going to pull back the curtain on that hidden world of 4G and follow a single piece of your data on its absolutely incredible journey. So, what really happens in that split second after you hit send on a message or start loading a web page? I mean, really. We're going to trace that exact path right from the palm of your hand, through the air, deep into the secret brain of the mobile network, and all the way out to the internet and back again. So let's start our journey right where it all begins, with the device in your hand. Before your phone can send a single byte of data, it first has to prove who it is to the network. You can kind of think of it like needing a digital passport just to get online. In all the technical manuals, your phone is called user equipment, or just UE, but the real magic, the real star of the show, is that tiny little SIM card. This is your phone's digital passport. It holds a globally unique ID number, your subscriber identity, that lets it identify itself to your home network, or even connect to other networks when you're traveling the world. Okay, so it's got its passport ready to go. Now your phone's first big challenge is just reaching the network. And it does this by turning your data into a radio wave and, well, basically shouting it out into the world. Now, here's something that might actually blow your mind. Your phone transmits its signal with only about 0.2 watts of power. That is incredibly weak. This faint little signal can only travel a few kilometers, tops, before it just fades into nothing. So how on earth does a whisper like that reach a network that spans the entire country? Well, the answer is this massive, invisible web of cell towers. In 4G lingo, the technical name for one of these is an eNodeB. Your mobile operator has put tens of thousands of these things all across the country, creating these overlapping cells of coverage. It's all designed to make sure that your weak little phone signal almost always has a tower nearby that's listening and ready to catch it. And the design of this web is really, really strategic. See, out in rural areas, the goal is simple: coverage. You just need enough towers so that you're always in range of at least one. But in a dense city, the problem totally flips. It's not about range anymore. It's all about capacity. This is exactly why your video might start buffering in a crowded stadium. The network needs enough stations to handle that immense data traffic from thousands of people all trying to get online at the exact same time. All right, so the cell tower has caught that whisper of a signal. But where does it go from there? This is where we leave the airwaves behind. Your data now enters the super high-speed fiber optic backbone of the network. It's a hidden world called the Evolved Packet Core, or EPC. So yeah, welcome to the network's brain. The very first stop for our data packet inside the EPC is the serving gateway, or SGW. And honestly, the best way to think of this thing is like a regional post office. It collects all the data packets from all the cell towers in a whole area and acts as the central sorting hub, sending them on to their next destination. From that regional post office, our little data packet heads to what you could call Grand Central Station, the Packet Gateway, or PGW. This thing is the single most important gateway in the whole network. It's the one and only entry and exit point that connects the mobile operator's entire private world to the huge public internet. Now, moving data is one thing, but the network also needs a really powerful control system to manage everything. And that's where the Home Subscriber Server, or HSS, comes in. This is the network's master database. Think of it as a highly secure digital vault that holds the profile for every single subscriber, what services you're allowed to use, and, crucially, your secret security keys. And if the HSS is the vault, then the Mobility Management Entity, or MME, is the air traffic controller. This is the true brain of the whole operation. The MME manages pretty much everything. It authenticates your phone when it first connects, it tracks your general location, and it orchestrates all those seamless handovers between cell towers as you move around. So all the pieces are in place. Your phone is talking to a tower, that tower is connected to the core network. But before a single bit of your actual data can flow, the network has to ask one critical question: are you really who you say you are? This all happens through this brilliant process called a challenge response. It's basically a secret handshake. First, the network sends your phone a random number. That's the challenge. Second, your SIM card uses its unique secret key to do a complex calculation on that number, and it sends the answer back. That's the response. Finally, the network, which has your secret key stored securely way back in the HSS, does the exact same calculation. If the answers match, you're in. And here's the crucial point. The real secret to the entire system's security is that master key stored on your SIM card is never transmitted. Not over the air, not through the network. Ever. Only the results of the calculation is sent, which means an eavesdropper just can't steal your key. It's what makes the whole system so incredibly secure. And authentication is just the beginning. 4G security is built in layers. I mean, once you're authenticated, powerful encryption scrambles all your data. Integrity checks make sure nothing gets altered on the way, and the network even gives you a temporary ID, so your permanent one isn't just being broadcast everywhere, which prevents you from being tracked across the network. Okay, so you're authenticated, you're secure, your data is flowing, but what happens when you're not actively using your phone? Or what about when you're driving down the highway? How does the network manage your connection both efficiently and, seamlessly? Well, the network is incredibly smart about saving your phone's battery. When you're actively browsing, your phone is in connected mode. But the second you stop, it drops into idle mode. The radio connection pauses, which saves a ton of power. The network still knows your general location, like, say, a group of a dozen cells, so if a notification comes in, it can quickly page your phone to wake it up and reestablish that connection instantly. So what about when you're on the move, like in a car? This is where the magic of the handover comes in. Think of it as a 4-stage dance. 1. Your phone is constantly measuring the signal strength of all the nearby towers. 2. It reports these measurements back to the network. 3. When the network sees a stronger tower is available, it prepares that new tower to take over. And 4. At the absolute perfect moment, it commands your phone to switch. And this all happens in milliseconds, so your call never ever drops. And there you have it. From just one tap, your data becomes a radio wave, gets caught by a cell tower, and dives deep into the network's core. It proves its identity with a secret handshake, it navigates through gateways, and it's kept connected on the move by these seamless handovers, all before it even reaches the global internet. It's this incredible symphony of technology, happening billions of times a day, literally in the blink of an eye. This invisible architecture, this is what enabled the entire world of mobile apps, of video streaming, and the connected life that we all know today. I mean, it basically built our modern world. And that really makes you wonder, with technology like this as the foundation, what in the world will the next generation build on top of it?